Chapter 4, Section 26, Detecting Data Inconsistency Using Regular Expression. This section covers what is data consistency, common types of data inconsistency, how to automatically detect inconsistency using regular expression. Let's start with the definition of data consistency. Simply put, data consistency refers to the state where all data in a dataset adheres to uniform rules and standards. This includes having consistent formats, values, and structure across all data points. Consistency ensures that data can be accurately processed, compared, and interpreted, laying a strong foundation for data analysis and machine learning models. Inconsistent data can introduce errors in analysis and models, leading to unreliable results. There are three common issues with inconsistent data. Mismatched categories. For example, categories like cells, and cells may represent the same entity but are treated as distinct due to case sensitivity or typographical differences. Inconsistent formats. This includes variations in date formats such as MMDDYYYY versus YYYYMMDD, or mixed numeric scales like kilograms and pounds. Irregular naming conventions. These often occur in textual data where names, abbreviations, or symbols are used inconsistently. For example, product A, product small a, and product A might all refer to the same product but are stored differently. Let's explore how to detect inconsistencies within our dataset. This is a crucial first step in the data cleaning process, as it enables you to identify the specific issues that need to be resolved. There are two primary approaches to detecting inconsistencies: manual inspections and automated detection. Manual inspections involve visually scanning the dataset or using simple tools like Excel to identify irregularities. While this approach can be effective for small datasets, it becomes impractical for large-scale datasets due to time constraints and the risk of overlooking subtle issues. Automated detection is the preferred method for handling large or complex datasets. Using programming tools like Python, you can efficiently identify inconsistencies such as mismatched categories or irregular naming conventions. Regular expressions and fuzzy matching are popular tools to automate inconsistency detection. Regular expressions. Regular expressions are useful for detecting patterns in textual data. For instance, they can identify inconsistent data formats, phone numbers, or other structured data irregularities. Fuzzy matching. Fuzzy matching is particularly useful for detecting similar but not identical entries, such as product-A and product A. This technique calculates the similarity score between entries to identify potential inconsistencies. Let's look at an example of detecting mismatched categories. Here, we have a dataset with a categorical variable, department, which contains entries such as cells, and cell. These represent the same category but are treated as distinct due to inconsistencies. Using Python, we can identify unique and mismatched values to correct them. By applying unique function to the variable, we can show the unique values contained in the variable. It is useful when the variable contains only a small number of unique values, and we can easily identify the similar but distinct values. However, if the variable contains many unique values, visual check is difficult. Simply displaying unique values does not adequately detect inconsistencies. To improve this, we can leverage regular expression to identify inconsistent categories. First, import re module. This module provides us with tools for working with regular expressions. Let's create a function to detect inconsistency using regular expressions. This function, detect_inconsistencies, is designed to identify entries in a dataset that match a specific pattern using regular expressions. This function takes a column of data and a regex pattern as inputs. It searches for entries in the column that match the regex pattern. And it returns a list of all entries in the column that match the pattern. This is useful for detecting inconsistencies or patterns in categorical data, such as spelling variations or case differences. Let's explore this line in more detail. This part, entry for entry in column, iterates through all the entries in the column. Next, this part, re-search, pattern, entry, re-ignore case, searches for the regex pattern in each entry. The re-ignore case flag ensures that the search is case insensitive. And if re-search only includes entries that match the pattern in the output list. Next, set the regex pattern to input as the second argument of the function. Here, we need to set a regex pattern to detect entries related to cells. We set a regular expression pattern to detect entries that can be considered as cells, regardless of whether they are written in uppercase or lowercase, and whether they appear in singular or plural form. If you are new to regular expression, please be patient. I will provide more detailed explanation of this expression in the next slide. Next, apply the function by inputting the data frame column as the first argument and the regex pattern as the second argument. By printing the result, we can obtain entries that can be considered as cells. Let me break down the regex pattern we set here. First, the caret indicates the start of the string. The pattern must match from the beginning of the string. Entries like cells and cell will be included with the case insensitivity. The reason of why cell is also included will be explained later. Entries like marketing sales will not be included because sales is not at the beginning. The next part, cell, matches the exact sequence of the characters S, A, L, E in order. The pattern is case sensitive by default. So, in the function we defined above, we need to use re-ignore case to make it case insensitive. The next is S question. The approach means the string should match the character S 0 or 1 time. This makes the S optional so that the regex will match both cell and cells. Finally, the $sign indicates the end of the string. It means that the pattern must match until the end of the string. So, the expression matches cell and cells, but does not match cell's depth because the string continues after cells. This table summarizes the pattern matches in this example. By changing the Regex setting, we can detect various forms of inconsistency. Thank you for watching. Please thumbs up and subscribe to my channel.